Hello. So I'm going to talk about mensuration in this video. So let's start with 2D shape. Okay. Let me decrease my DPI. Okay. So let's start with 2D shapes first, and we move on to 3D shapes, and then we move on to problems. So let's start. So here I have a circle. This looks terrible, but okay. Let's talk about circle first. So there are 2 or 3 points to talk about circle. Uh, this is the center of the circle. Let's call it C, and the distance from the center of the circle to the end point is known as radius of the circle. And the distance between these two endpoints, this is known as diameter of the circle. So as you can see that diameter is 2 times the radius of the circle. So if we add the radius twice, we get the diameter of the circle, and this is the center. And to calculate the area of this circle, this thing right here, the area of the circle is pi times r squared, pi times radius squared. So uh, here pi is an irrational number, pi is a constant. Pi is an irrational number. Irrational number means non-terminating. So it never ends after decimal point. It goes like 3.14 and so on. It never ends after decimal point. So for calculation purpose in real life, we round off this number and we simply use 3.14, which gives accurate calculation, accurate with precision. We get answer with precision. Not perfect answer, but the error is negligible. So uh, instead of using this 3.14 decimal, we can also use 22 upon 7. This is also 3.14. So for to make calculations easier, we can use 22 over 7. We can use 22 over 7. Okay. So one more thing I want to talk about is the length of this circle. If I cut the circle in here and make this like a straight thread, and let's call the length of the thread is L. So how can we find the length of this thread? So to find that, uh, I'm going to use a thing. Okay, let me teach you a concept. So let's say I take a small part in this circle, and this is the angle theta. So let's say this particular angle is theta, and r is the radius of this thing, uh, small part of the circle. And I need to find the length of this thing, this particular length. How do I find this particular length? Marked with green, this particular length. To let's say the length of this right, this thing is curved thing is L. So L is basically theta times r, theta into r. How do we get there? Uh, if I make if I drew a straight line here, draw perpendicular here, and let's say this is sorry, not that. Sorry, it is not 90 degrees. This is 90 degrees. Okay, here. So I drew a perpendicular from there, and this is 90 degrees. So as if we rotate this thing, and we can see that the length of this is approximately equal to this. So by using sine theta is equal to opposite L over hypotenuse R. So when theta is very small, this curved part is negligible. This curved part becomes like this when theta is very small, infinitely small. So this part becomes straight. If we zoom in too microscopically, we are talking here microscopically. If we zoom in too much, so this part here L and this is radius R. It still remains same. The radius remains same. So when theta is very small, sine theta, we can approximate sine theta as theta. So here we get theta as length upon radius. So if we multiply both sides by radius, we get length is equal to radius times the angle. Remember, the angle is in radians. It is a term radians. I'm going to talk about it later. So just remember this thing. The this length is radius times the angle theta. So for a perfect circle, uh, let's say this is a circle. Okay, I drew a circle and this is radius r. If I measure angle from this is a full 360 degrees angle. 360 degrees angle. So in radians, we can write 360 degrees as 2 times pi. Okay, 2 times pi. So I can write 360 degrees as 2 times pi. And we know that to find this all length of this circle, we can use radius times uh, the angle. The angle is 2 pi. Remember, we have to use angle in radians. So we get length of this circle as 2 times pi. And the length of the circle is also known as circumference. Sorry, circumference of the circle. So if you didn't understand this part, so please ignore that. You can simply remember the circumference of the formula as 2 times pi times r. Okay. So this is some points to be remembered in for circle in 2D shapes. Let's move on to the next shape. So in second shape, we got here a square and a rectangle. Okay, let me talk about rectangle also. Let's talk about rectangle also. Mm, okay, this right here is a rectangle, and this is, let's call this length of the rectangle, and this is the width, or we can say breadth of the rectangle. If we were to calculate area of this rectangle, so basically area is length times breadth. And for a square, all sides are equal. For a square is basically a rectangle, but if the all sides are same, then we call it a square. A square is a rectangle. So by using the rectangle, like we used in rectangle calculating area length into breadth, we can also use in length. For square, length is a, breadth is also a. So a times a is a squared. So area of the circle, area of the square is a square, and uh, like the circle, for circle, the length of this thread is 2 pi r. We called it circumference. For rectangle and square, we use a term called perimeter. So let's denote perimeter with P. So perimeter is also same, the length of the thread. So what is the length of this thread? A, 4 times. So it is 4 times A. And perimeter of this rectangle is the length is 2 times. So 2 times length plus The length, the breadth is also 2 times, twice. So I can take common 2 from this, and this comes out to be 2 into L plus B. So this is the perimeter formula for square. You can simply add thus all the sides to get perimeter. You don't have to remember this formula. So for teaching purposes, I told you the formula also. Okay. So let's move on to triangles. Oh, sorry, number 3. For triangle, you don't need to remember anything. Just know this. Okay. This is the height of the triangle, and this is the base of the triangle. To find area, we have formula 1 by 2 times base times height. This is the area of the triangle formula. Uh, so there is a special triangle. It is known as equilateral triangle. In equilateral triangle, the all sides are equal. If all sides are equal, we denote it by like this, double lines. A. Okay, it is not looking good. A. To calculate this area, let's say we have given sides only. We have to calculate the area. We don't know the height. Okay, so let's draw a line. This is, let's say this is height, and if you look closely, you can see that this is a right angle triangle. Here we have 90 degrees. So like, uh, we can use a Pythagoras theorem in here, and this for this right angle triangle, the base is a by 2. This right thing, this is the half of the a, so it is a by 2. So let me draw the right angle triangle, that right angle triangle here. Okay, this thing right here is a over 2. I need to find the height. This is the height, and this is the hypotenuse. So for a right angle triangle, the hypotenuse squared is equal to the height squared plus base squared. So uh, let me write it there. A square is equal to h squared plus a by 2 whole squared. So remember this thing for a right angle triangle. Mm, This is 90 degrees. So we need to find a h here. H. We need to isolate h. So this is h squared. This becomes a square over 2 square is 4. So let's subtract both sides by a square over 4. This gets cancelled, and we are left with h squared is equal to a square minus a square over 4. So if I multiply and divide by a in this thing, so the denominator becomes same. We can manually do the calculation up here. So 4a square minus a square is 3a squared. And if I take square root on both sides for this thing, square root means power 1 by 2, whole power 1 by 2. So by using property a power m whole power n, it is a power m times n. So this 2 gets multiplied. When this 2 gets multiplied, then 2 gets cancelled. We are left with h only. So this becomes root 3, and a squared square root gets cancelled, and 4 is 2 squared. So 2 squared whole power 1 by 2, 2 gets cancelled, and we are left with 2 only. It's- Sorry for swearing. Okay, 2. Okay, uh, we got the height of the triangle as root 3 over 2. Root 3 a over 2. So what are we left with? We have to calculate now the area of the triangle. So this the area of this right angle triangle is half times base is a. Okay, so we have to take full base. This is not a right angle triangle. Now we are dealing with full triangle. So full base a, and the height is root 3 a over 2. Uh, Nothing gets cancelled, and we got root 3 a square over 4. So this is the area for a equilateral triangle. Okay. So I've talked about triangles, I've talked about circles, and some basic things of rectangle, and rectangle and square. Let's move on to 3D shapes. So we are here 3D shapes. Okay, remember one thing. You need to remember all these formulas of 3D shapes to do any type of calculations. Okay, let's. I'm going to explain this thing. So, sorry, I'm going to explain the terminologies involving for cube, cuboid, sphere, and the hemisphere, cylinder, cone. What are these terminologies? CSA stands for curved surface area, and TSS stands for total surface area. Surface area means the area on the surface. It is different with volume. Volume is another thing. Volume is the space occupied by that object, that 3D object. So, did you get that? The space occupied by the 3D object is volume. The volume is all the product of that all the dimensions. What type of dimensions we have in 3D objects? We have length, we have breadth, we have length, breadth, and one more thing we add is height. We add height to the object, and that becomes a 3D object. So as we can see, we have length for this cuboid and breadth. So this is the triangle right here on the bottom. This is the triangle. Sorry for the interruption. Okay. Um, so basically, volume means the space occupied by the object, and curved surface area is the surface area which is curved. So let's see in the cube, which is curved surface area. So this this thing right here, you can see. I circle the thing. Then this is curved surface area. So curved surface area is excluding the plates. These plates you can see, excluding these plates, all the surface area is curved surface area. You can see it is curved, so it is known as curved surface area, and it is 4a squared because we have one, two, three, four square plates. So one square plate, the area is a squared. The sides are a, and the area becomes a squared. The for four plates, here we can see there are four plates involving in the for the curved surface area. So the curved surface area becomes 4a squared, and the total surface area is including this two plates also, top bottom plates also. So this, after adding this two, it becomes 6a squared. So I think this is enough. So let's move on to the cuboid. So basically, the volume of the cuboid is length into breadth into height. The all the product of the all the dimensions, and curved surface area is excluding excluding these two plates, now we are dealing with like this. We are dealing like this. Okay. So as you can see that for a this is a rectangle. Sorry, this is the rectangle. So this is the formula for curved surface area, and this is the formula for total surface area. As I said, we need to remember all the formulas. And going on to the sphere, sphere volume formula is 4 over 3 pi r cube, pi r cubed, and the curved surface area is 4 pi r squared, and the total surface area is also 4 pi r squared for the sphere. We can see that there is nothing that we can neglect, and all the surface is curved, and so yeah, the curved surface area is 4 pi r squared. Okay, so here comes hemisphere. Hemisphere is half of the sphere. So if the volume of the sphere is V, so volume of hemisphere becomes V over 2. So halving the volume, let's divide it by 2. So that's 2 cancelled with 2. This becomes 2 over 3 pi r cube. We can see that here 2 over 3 pi r cube is the volume. And now here comes some important part. This plate is a circle, and this does not include with curved surface area. We can see that curved surface area is this part only. This curved part only is the involves curved surface area. Okay, so by excluding that, if curved surface area of full sphere is 4 pi r squared, then for half sphere it becomes 2 pi r squared. It becomes half of the 4 pi r squared, and the total surface area, in total surface area we also include this area also, because we are dealing with total surface area. So it basically is a circular plate. Okay, for a circular plate and the radius is r, so circular plate area is pi r squared. If we add in the 2 pi r squared, it becomes 3 pi r squared. Okay, for hemisphere, this is for hemisphere. And for cylinders, we have uh, two circular plates attached with a height. With a So this is a cylinder. This is the volume of the cylinder, pi r squared h, and this is the curved surface area of this cylinder, 2 pi r times h. So uh, let's understand why this is 2 pi r times h. So if I take this a small part of this cylinder, which has radius r. So if I calculate the length, okay. Uh, Remember one thing: we are not seeing under this cylinder. We are only talking about outer area. Outer area is known as surface area. Okay, so if we see from outside, uh, we are dealing with circumference. Okay, if we talk about a circle, so what is the circumference of the circle? The circumference of the circle is 2 times pi times r, and we add another thing, height here. So if we multiply that by height, we can get all the curved surface area, the surface area of this curved thing. Yeah, that's it, to understand that. And the total surface area is adding this two things also, these two plate areas also. One plate area is pi r squared, and another plate is also pi r squared. So by adding those, it becomes 2 pi r h plus 2 pi r squared. Okay, so for a cone, this is the volume of the cone. 1 by 3 pi r squared h. And we have length, a term length also here. So as you can see that this thing right here is looks like a right angle triangle. So let me draw it here, right angle triangle here. Okay, this is r, this is angle 90, this is h, and this is length l. So by using Pythagoras theorem, we can write L square is equal to h square plus r squared. We can use this thing right here while calculating our while dealing with problems. Okay, so uh, the curved surface area of this thing only, excluding the plate. Okay, curved surface area, and this is total surface area. To calculate total surface area, we have to add this pi r squared to the curved surface area. So pi r l plus pi r squared. If we common out pi r, we can get r plus l. So that's it. It is a simplified form. Okay. So I think that's it for curved surface area, total surface area, and volume of 3D shapes. I'm going to use this table while dealing with problems. So let's move on to problems. Okay, let's see the problem. The Joker's cap is in the form of a right circular cone. So right circular cone means cone. Mm, So we are dealing with a cone whose base radius is 7 centimeter. Let's draw a cone. Okay, this is a cone, and the radius of the cone is given 7 centimeter. Base radius means the radius of this base. Okay, and the height is 24 centimeters. Okay, let's see the height. Here we have the height of the cone, and it is given as 24 centimeters. Okay, find the area of the sheet required to make such 10 such caps. Okay, so uh, we took a sheet. Let's say this is a random sheet, and we prepared after curving this. After curving that thing, we prepared a cone like this for Joker. Okay, so that means we are dealing with curved surface area only. In this case, you can see it is not involving any type of this thing. So we are dealing with curved surface area, and curved surface area CSA is the formula for cone. The formula for cone is pi times r times l. So pi times r times l. L is this length. So we don't know that length. So to calculate that, we know that this is a right angle triangle, and I can use L square is equal to h square plus r square by using Pythagoras theorem. And here we have h as 24 square plus, okay, L square, and r as 7 squared. So let's calculate that. 7 square is 49, and 24 squared, 24, 60, 24 times 24, 16, 4 times 2 is 8, 8, 8, 16, 16 plus 16 is 16 plus 6, sorry. Oh, fuck. Okay. Mm, 476 it is, I think. 49 plus 476. It becomes 5, 15, 5, 7, 12, 625. Okay. L squared is 625. 625 is 25 squared. If we compare those, we get L as 25. So as the unit is in centimeters, so we have to write L as 25 centimeters. So let's calculate. Pi is 22 over 7, and it is a constant. Okay, the radius is 7 centimeters and the length is 25 centimeters. So remember one thing, we are calculating for one cap only. We are calculating the area required for one cap. uh, to to make, okay, to find the area for 10 caps, we need to multiply it by 10. uh, Remember, multiplication means adding. So if I add 4 two times, so I can multiply 4 by 2 to do that. 4 into 2 is 8 and 4 plus 4 is also 8. So to find area for 10 caps, I can uh, manually add that area 10 times, or I can just simply multiply it by 10. Okay, so yeah, 7 7 gets cancelled. We are left with 27, sorry, 22. 22 times 25 times 10, and this centimeter gets multiplied, it becomes centimeter squared. Remember, area, the unit for area is unit squared. If we calculate anything area, let's say uh, I calculate 2, 3, and these are in meters, so the area will be 2 times 3 is 6 meters square. me- Meter squared. Okay, this is the unit for area. So let's multiply this. 2 times 5 is 10. 2 times 2 is 4. 5, 10, 14. And add this thing, 15. 2 to 4, 550 into 10. Again, one more 0. So this is the area. The area of sheet required to make 10 such caps. Okay, so this is the answer for this problem. It is not that complicated. Uh, just just remember these formulas. If Before remembering these formulas also, uh, I suggest you to practice. You to do problems by seeing this formula sheet. Okay, first you need to understand the language of the problem. What the question has asked before remembering those formulas also. Okay, so basically you need to know how to apply the formula before remembering it. So let's move on to problem number 2. A sports company was ordered to prepare 100 paper cylinders for taking shuttlecocks. The required dimensions of the cylinder are uh, length 35 centimeters, height, okay, 35 centimeter length or height, and its radius is 7 centimeters. Find the required area of thick paper sheet needed to make 100 cylinders. Find the area of thick paper sheet. Okay. So uh, they told us that this is a thick paper sheet. We curved that and prepared a cylinder which has a radius which has a radius of 7 centimeters, which has a radius of 7 centimeters and a height of 35 centimeters, and the height of 35 centimeters. Okay, so we need to find this particular area to make. Okay, if I find this one paper area, I can make one cylinder. If I need to find the area for 100 cylinders, I have to multiply it by I have to multiply the area by 100 to get for 100 cylinders, to get the area for 100 cylinders. So you can see that we need to calculate the curved surface area for this cylinder. Uh, okay, this area right here. Okay, okay. Uh, this area right here. This area right here is the curved surface area. So let's find out the curved surface area. So the curved surface area of a cylinder, CSA of a cylinder is, let's see, for a cylinder CSA is 2 pi RH, 2 times pi times radius times height. So 2 times 22 over 7 times radius is 7 centimeters, 7 centimeters, and height is 35 centimeters. So this 7 gets cancelled, and 2 times 22 times 35 centimeters squared. This is 44 times 35. Remember, we are calculating for one cylinder only. We need to multiply it by 100 after getting this answer. This is for one cylinder only. 4 times 5 is 20. 4 times 3 is 12 plus 2 14. 4 times 5 is 20. 20 and 14 is 34. 34. So I have to write 4 down here. And 4 times 3 is 12. 12 plus 3. Sorry. Yes, yeah. 34. 12 plus 3 is 15. So this is for one. This area is for one cylinder, to make one cylinder, and if I have to find area for 100, I need to multiply it by 100, and after multiplying by 100, we get this thing, CSA for 100 cylinders. Okay, this is the solution for this problem. Let's move on to next problem. Okay, one more thing. If in question there is mentioned that the lids are also given, so we have to consider then the total surface area. Okay, if we only consider the paper thing here, we have to find curved surface area. If I consider the end of the lids, these lids, the end of the cylinders, I have to consider the total surface area. So if I consider the total surface area, if I consider the both lids, so total surface area is 2 pi RH plus 2 times pi r squared. Okay, so we got, wait a second, what we got, 154,000. 154,000 plus 2 times 22 over 7 times 7 times 7. Remember, only if they have mentioned that uh, the we have to calculate for paper lids also. Okay, so now this becomes 44 times 7. So for calculate that, 4 times 7, 28. 28 plus 2 is 30. Mm, Okay, it's correct. So this becomes uh, for 100, we have to multiply this by 100. Okay, so this becomes 3800, 30800, and 1 5, sorry, 0004. Okay, 008481. So this is the total surface area, centimeter square. To make 100 cylinders, including the paper and including the both end lids. Okay, so let's move on to the next problem. So this is a good problem. This is a very good problem to understand the concept of volume. So let's read it and solve it. Metallic sphere of spheres. Sphere of radius. How is this? Spheres of radii. For multiple radiuses. Radii. Okay, ignore the grammar mistakes. Let's move on to problem. Metallic spheres of radii 6 centimeter, 8 centimeter, and 10 centimeter respectively are melted to form a single solid sphere. Find the radius of the resulting sphere. So we this looks very simple, but we need to know whether we have to use curved surface area or total surface area or volume in this case. So as I mentioned, surface area is only the area of outer surface. If we need to involve any type of inner thing, we need to involve a full circle. We need to use volume. So we have a circle with radius 6, a big with a circle with radius 8, a bigger circle with radius 10. We melted these three circles and form a bigger circle. So as we can see that we are not dealing with surface areas. So we yes, we melted these three metallic spheres and created a massive sphere. Let's call it its radius as r. Okay. So what are we doing here is we are uh, converting this metallic sphere's volume into this big sphere volume. So to write the equation, the volume of big sphere is equal to volume of sphere 1 plus volume of sphere 2 plus volume of sphere 3. So the volume of big sphere, the formula for volume of sphere is 4 by 3 pi r cube. So this is 4 over 3 pi capital R cube. Let's call it capital R. And this is 4 by 3 pi times, uh, sorry, okay, small r1 cube. Okay, let's call it small r1, small r2, small r3. And for second one is 4 by 3 pi r2 cube. And for third one it is 4 by 3 pi r3 cube. So let's write this down. 4 by 3 pi capital R cube is equal to, if I take common 4 by 3 pi, I am left with R1 cube plus R2 cube plus R3 cube. Okay, cube. So 4 by 3 pi and 4 by 3 pi gets cancelled, and I'm left with this equation. Capital R cube is equal to R1 cube plus R2 cube plus R3 cube. So this is the radius of the big sphere. So capital R is the radius of the big sphere. Let me write it here also. Okay. Capital R is the radius of the big sphere. So to isolate capital R, what I'm going to do is I'm going to take power 1 by 3 on both sides. Okay. So 3 gets cancelled and I'm left with R as R1 cube plus R2 cube plus R3 cube. So now we have solved the equation for capital R. So let's plug in the values of the small radii. So R1 is 6 cube plus R2 is 8 and 10. Okay, 8 and 10. Yeah, that's it. 8 cube plus 10 cube whole power 1 by 3. So let me calculate the and let's calculate 36 times 6 plus 64 times 8, which is 8 cube plus 1000, which is 1728. 1728. And sorry. And to take power, where I can take power. I'm divided by 3. Sorry. Power 1 by 3 is 0.33. Repeating. So it is comes out to be 12 approximately. So the answer for this problem is 12 centimeters. Okay. It is a good problem to understand the concept of volumes. Okay, so let's move on to next problem. Let's move on to the next problem. Yeah, this problem. We have 2 more. So let's do this problem. So we have how many silver coins? 1.75 centimeter in diameter and thickness as 2 millimeters need to be melted to form a cuboid of dimensions this. Okay, so this problem is concept is also involved with volume. So we have a cuboid. Okay, something like that. We have a cuboid. With okay, the volume of cuboid is length into breadth into height. So the volume is given, the dimensions are given. So we can, by comparing with that, we can get length as 5.5 centimeters and breadth as 10 centimeters and height as 3.5 centimeters. And we have a coin. We have a coin with this thickness. This is the thickness of the coin, and this is the diameter. Diameter is full length. D is 2 millimeters. So for calculation, we need the radius of this coin. So let me find out the radius. zoom in to write clearly. So the radius is diameter over 2, half of the diameter. This thing is radius, so it becomes 1 millimeter. So the radius becomes 1 millimeter, and this is given as 1.75 centimeter. Diameter and thickness. Oh, sorry. Thickness is 2. Okay, my bad. Let's say this is a coin. Okay, thickness is 2 millimeters, and the diameter is 1.75 centimeters. Okay, and so the sorry, the radius becomes 1.75 over 2. So if we zoom in into this coin, it looks like a cylinder. Okay, so the the height of the cylinder is very low. Uh, so for understanding purposes, I'm only drawing like this cylinder. So this height is 2 millimeters, and the radius is this 1.75 over 2 centimeters. So what have we done? Uh, we used a coin and converted into a cuboid. We use several coins. So let's call we use X number of coins and converted it into the cuboid. So what have we done? We converted X number of silver. We taken X number of silver coins and melted them and converted them into cuboid. So we changed the volume of the coins. So the volume of this X coins and the volume of this cuboid are same. So let's write down the equation for that. Volume of cuboid is length into breadth into height of the cuboid, and the volume of these things are, so uh, for one cylinder volume is, let's see the formula sheet. Cylinder volume is pi r squared h. So for one cylinder it is pi r squared h of cylinder. This is h of cuboid. This h of cylinder. So this is for one. If we need to find for x, we are dealing with x number of coins, so I have to multiply that by x. So now this equation is correct. So length into breadth, 5.5 into 10 into 3.5. So this volume is 5.5 centimeters into, okay, 5.5, 10 and 3.5. 5.5, 10 and 3.5. The pi value is 22 over 7, and the radius of the coin is 1.75 over 2 into 1.75 over 2. I'm writing, okay, I'm writing it like this. Over 2 into height of the cylinder is 2 millimeters. Okay, 2 millimeters into x. So the dimensions of the left side are in centimeters. So this is centimeters times centimeter times centimeters. That is centimeter cubed. I have to write that centimeter cubed. Let me erase this thing. Okay. So this is centimeter cubed. Okay. And on the right side, we have radius in centimeters and this also in centimeters. But we have this thing in millimeters, so we need to convert millimeters into centimeters. So 1 centimeter is 100 millimeters. Then if we solve for 1 millimeter, we get 1/100 centimeters. Okay, wait a minute. So, okay, my bad. This is not 100, this is 10. Okay, 1 centimeter is 10 millimeters. Sorry, 10 millimeters, then 1 millimeter will become 1/10 centimeters. So I have to write this thing as uh, 2 into 1/10 centimeters, so that the units becomes same. We cannot calculate anything without the units being same. Okay, so let me write it down like this: 5.5 into 10 into 3.5 and 22/7, and this thing is 1.75. Is it 1.75? Yeah, 1.75, and 1.75 75, and this becomes 4. 2 times 2 is 4, and this is 2 into 1/10. So into x. Okay, so now the units are same. Now we can calculate anything. Okay, so let's calculate. So let me calculate and write down the answer. So this x is comes out to be 200. Right? 200 times 2 is 400. Okay. Okay, I calculated in rough. So x is number of coins. So we need 400 number of coins to do this thing, to convert this 400 number of coins into a cuboid. So let's go to this problem. How many problems do we would have? Okay. A 20 meter, a 20 meter, a 20 meter deep well with diameter 7 centimeter. Okay. Okay. Let's say this is a deep well. Okay, deep well is in the form of cylinder with diameter is this thing. So let's calculate the radius. We only deal with radius. So radius is 7/2 centimeters. This dug and digging is evenly spread out in the platform. Okay, so uh, it is spread out over the platform. The mud, the mud we have dig is spread out over the platform. Okay, let's spread out. Okay, like this. Platform 22 meters into 14 meters. Find the height of the platform. So uh, it is like this, I think. It's like this. So let's say this is the height of the platform. Like this. This is the height of the platform, and the area of this platform is given. So as we can see that this is the area of the platform, and it is given as this thing, 22 times 14 meters. So 22 into 14, meter into meter is meter squared. As I said before, meter squared is a unit of area. So we have area given. So uh, we can see that we have dug the mud and spread out evenly like this, and we have changed the volume. So this is a cylinder, we converted into this like this. So we changed the volume. So the volume of the mud inside this is equal to volume of this. So we can equate the volumes of both this cylinder and this cylinder. So for this cylinder, we do not need to worry about formula. We have area given as this. So we simply need to multiply this area 22 times 14 meter squared into the height, into this height, to get the volume. So basically remember, volume is also area times height. As you can see that volume is length into breadth into height. If length and breadth are given, length and breadth is basically area. So it is area times height. Area is given, height is what we need to find for this platform. And for cylinder, we need to find the volume of the cylinder. So for this cylinder height is 20 meters. Okay, the volume of cylinder is pi r squared h, I guess. Yeah, pi r squared h. So volume of cylinder is pi times radius for the cylinder is 7 over 2 centimeters. 7 over 2 centimeters. And we need to convert centimeters into meters because we are dealing with meters on left side. So let's convert centimeters. So 100 centimeters is equal to 1 meter. So 1 centimeters is going to be equal to 1 over 100 centimeters if we divide both sides by 100. Okay, so this is going to be 1 over 100 meters, and 7 over 2 into 1 over 100 centimeters. 100 meters, sorry, meters, pi r squared, and height of the cylinder, the cylinder is uh, 20 meters. It is in meters, so we don't need to worry about that. So we can see that the height also comes out to be in meters. Okay, we are dealing in meters only right now, so we do not need to worry about anything. We can just calculate simply. So um, oh, shit, okay, this 7 gets cancelled out where this 7 twos are 14, and this pi is 22 over 7. Let me write it here clearly. 22 into 2 into h is equal to 22 over 7 into 7 over 100 into 100. And this thing right here is, okay, 7 into 1 by 4. This 2's multiply and become 1 by 4, and we have 20 also up here. Okay, so this 22 gets cancelled, and this 7 get cancelled, and this 2 get cancelled with this. 2 tens are 20, and h is equal to 1 over 100 times 100 into 10 over 4.